Hello, everybody, and welcome to this first lecture of Medicinal Chemistry of Semester 4. Today, we are going to commence with physicochemical properties, and today's lecture will cover the first physicochemical property that affects the drugs, that is ionization. So, let us understand ionization. Okay. Given I am Dr. Urmila Joshi. If you like the lecture, please hit the like button and subscribe to the channel. Given here is my mail ID, and if you have any difficulties in the lecture, please do not hesitate to write to me at this mail ID and I will reply. So, let us try to understand first the passage of drug in the human body. Whether it is administered by oral route or by parenteral route, the drug dissolves in the body fluids. After it dissolves in the body fluids, it passes through a ranges of pH. If it is administered orally, it survives intestinal bacteria and their enzymes and the liver metabolism. This is called as first pass metabolism. It crosses the membranes and reaches the target organs. In doing so, it avoids reaching the undesired organs like brain. It binds to the desired receptors, and then finally, after producing action, it gets excreted. Okay, so why are physicochemical properties so important? Just now we have seen that the passage of the drug through body involves a lot of complex processes, lot of complex barriers, etc. And many of these processes can be either modeled or modulated using physicochemical properties. What are physicochemical properties? The physical properties of the drug molecule and the chemical properties of the drug molecule. And so these physicochemical properties are very important in trying to understand the drug action. So the first of the physicochemical property is ionization. The acidity or the basicity of a compound plays a major role in controlling absorption, transport, binding, and elimination. Okay, ionization indicates protonation or deprotonation resulting in charged molecules or ions. We will see how these are produced in the next slide. About 85% of the marketed drugs contain functional groups that can be ionized to some extent at physiological pH, which has a wide range from 1.5 to 8. So, why is ionization important? Just try to understand that the drugs need to cross various membranes to reach the site of action. If the site of action is liver and the drug is administered orally, the drug needs to cross the GI membrane and then enter the liver cells. There can be other examples. If the drug is administered parenterally and if muscle is the site of action, then the drug has to cross the membranes to reach the muscle. Okay, so for this, understanding the structure of the membrane is important, and we have seen this in the past that the cell membranes are lipophilic in nature. Okay, they are made up of phospholipids and some polar head group regions with some proteins inserted. So these are the lipid tails, and the round part that is shown over here is the polar head group region. All these are phospholipids. Now, because they are lipidic in nature, most of the absorption occurs in unionized form. And so, pH is very important because the ionization is dependent upon pH. Given here are the pH ranges of some of the important organs. Just have a look at it. Stomach has a pH of about 1.4 to 7, depending upon the status, that is fasting or fed. Small intestine 6.45. Duodenum in fasting state 4.4 to 6, and in the fed state it is 5.2 to 6.2. So the blood has a pH of 7.4. So drug comes across a variety of pHs, and to cross the membranes at various junctions, it has to be in the unionized form. Now, when the pK, you are aware of the pKa of the compound, I suppose. pKa is the negative log of Ka. Okay. If you know pKa and if you know the pH, you can calculate the proportion of ionized and unionized species in the body fluid. pKa decides the ionization, and this also influences solubility of the drug in body fluids. Just see, more ionized drugs are more soluble, but the absorption occurs in the unionized form. So, the relationship between pKa and biological activity is likely to be parabolic. When the pKa is less and the other extreme where pKa is very high, the absorption and the solubility balance will be disturbed, and so the relationship is likely to be parabolic. We will see this in the subsequent slides. Now let us see calculation of ionization. Ka is the ionization constant. Let me write this reaction. This is an acid. Okay. This acid ionizes to H plus and A minus. So the ionization constant Ka can be written as concentration of H plus and A minus divided by concentration of the unionized acid. Okay. Ka is equal to H plus H plus into A minus upon HA. Taking log of both the sides, log to the base 10 of Ka is equal to log to the base 10 of H plus A minus upon HA. Okay. Now, we can separate this log of H plus log of A minus upon HA. So, taking negative of either sides, minus pK is equal to minus pH plus log of A minus upon HA plus. Now, taking this on the other side and this on this side, pH is equal to pKa plus log of A minus upon HA, where A minus is the conjugate base and HA is the original acid. Okay. Now, just try to understand, if we reverse this, okay, pKa will be equal to pH plus log of acid upon base. Base is the conjugate base. Let us see calculation of ionization. This is a phenylpropanolamine. Okay, the name of the compound is phenylpropanolamine. This phenylpropanolamine, as you can see from the structure, is a base, and its conjugate acid will be NH3 plus, the ionized form. Okay, this is an ionized form. The pKa of this compound, phenylpropanolamine, is given to be 9.4. And the question is, calculate percent ionization of phenylpropanolamine at pH 7.4. The formula that we will be using, the last one, that is this, pKa is equal to pH plus log of acid upon base, that is unionized upon ionized. Okay. So 9.4 is equal to 7.4 plus log of acid upon base. Taking this on the other side, 2 is equal to log of acid upon base. Now, if you take antilog on both the sides, it will be 100 upon 1 is equal to acid upon base. Okay. So, if the acid or the unionized, the percentage ionization then can be calculated to be, just see, 99%. You can, from the Foy 7th edition, check for percentage ionization of amobarbital. Something similar to this in a solved problem form is given in Foy 7th edition. Check for that and answer the question why amobarbital is acidic in nature. Draw the structure and answer this question. Okay. Effect of substituents on ionization. The substituents have similar effect on the ionization of different series of compounds. Look at this is benzoic acid and this is pyridine. Now substituted benzoic acids and substituted pyridines both have a similar sort of effect. It is nearly a straight line, similar sort of effect of different substituents. Okay, that means if you add, this is substituted benzoic acid, this is substituted pyridine. When you add 4-chloro to it, what happens? This increases by 0.2 and this also increases. It may not increase by 0.2, but it increases by a similar amount. Same is the case with 3-fluoro, 3-chloro, etc. Okay. So this allows for prediction of pKa of molecules before they are even made. And this, in a very, very refined form, is made use of in software development for pKa prediction. Now, I said that the relationship is parabolic. Let us see why this happens. This is a sulfonamide. There is H over here. Okay. This sulfonamide is acidic in nature. Okay. When it is acidic, it is less soluble because it does not ionize very easily. Because it does not ionize very easily, it doesn't dissolve very easily. Whereas compound on this side, this is a ionized sulfonamide. Just have a look at it, ionized sulfonamide. This ionized sulfonamide dissolves very easily, but it dissolves very easily, but it doesn't go to unionized form very easily, and so it is not absorbed easily. Whereas compounds in this range, if you can see compounds in this range, they are dissolving also and they are absorbed also. So that is the parabolic curve of sulfonamides. There is another application of sulfonamide ionization. Sulfonamides, as you know, are weak acids. I mentioned over here that this hydrogen is acidic in nature and this can be lost. So they are weak acids. Okay. Weak acids are insoluble at acidic pH, you know. Weak acids will dissolve in alkaline pH. So weak acids are insoluble at acidic pH, but the urine pH is acidic. And so sulfonamides may precipitate as crystals. And this may cause a very serious concern. Sulfonamides precipitating in the urinary tract as crystals may cause a serious concern. A way out to this is going to be alkalinization of urine and hydration. Advise the patient to have lot of water so that sulfonamide dissolves to a greater extent. Secondly, alkalinization of urine will cause solubilization of sulfonamides and their easy excretion. So that is a direct application of ionization and its effects. So with this, we complete the chapter of ionization. If you have any difficulty, please feel free to write to me on mail and I will answer. Please see to it that you like the video and subscribe the channel. Thank you.